Today, we try to learn the concept of electric current. Matter is made up of atoms. An atom consists of a nucleus at the center and some electrons moving around. In some materials, there are electrons which do not belong to a particular atom, for example, like metals. Those electrons, we call them as free electrons. They can free to move in a material. Nonmetals have no free electrons. Now, let's consider a metal wire in a circuit which is not connected to a dry cell. We found that the free electrons move randomly in all directions. But when a metal wire connected to a dry cell in a closed circuit, the free electrons move in the same direction. The free electrons move from a negative pole of dry cell to the positive pole. The flow of these three electrons forms an electric current. Well, we can use a water pipe system to analog the concept of electric current in a circuit. In a water pipe system, the water pump like a dry cell, the water pipe like a closed circuit, the water turbine like the light bulb, and the water in the pipe is the electric current. Well, we found that the water pipe force pump the water through the water pipe to the water turbine. Like the dry cell force the electrons flowing through the circuit to the light bulb. Now, let's have a short summary. So we know that metals have a lot of free electrons. The flow of electrons in the same direction forms an electric current. Well, before electrons were discovered, an electric current was thought to be a flow of positive electric charges, which move from the positive pole to the negative pole through the wire. That is what we call the conventional direction of electric current. And now, the direction of current, we still use the conventional direction, which is flowing from the positive terminal to the negative terminal of the battery. And now, let's see how we can measure the electric current. To measure electric current, we can use an ammeter. Electric current is measured in amps. The unit, we use a capital A to show it. Some electric currents are measured in milliamps. The unit, we use mA. And now, let's see how we can connect the ammeter to the circuit. Well, we should always connect the red terminal of the ammeter towards the positive pole of the dry cell, and the black terminal of the ammeter to the negative pole. Now, I will play the video to you and let you know how does the brightness of the light bulb change with the electric current in the circuit.
Connect a circuit like this. What happens when you close the switch? Now, connect the circuit with an ammeter. Close the switch again and record the reading of the ammeter. Change the position of the ammeter to the other side of the dry cell. Close the switch and record the reading of the ammeter again. Is the reading the same as that of the last result? Repeat the experiment with 2 dry cells. How does the reading of the ammeter change? How does the brightness of the bulb change?
Well, from the video, so we found that when an electric current in the circuit becomes larger, the brightness of the light bulb increases. Now, so you should learn these 2 key points. An ammeter is used to measure the size of an electric current. The units of electric current are amp and milliamp.